My name is Joe McDonough. I do operations engineering for Rapid7, an information security firm based out of Boston. We acquired Metasploit recently, which might be what you heard of us. Networking is not my strong point, funny enough, systems is, but today I'm going to show you a nice model, a systems model as applied to network security. You might be wondering why OpenBSD. It's kind of a no-brainer if you've ever used packet filter on OpenBSD. Anybody want to show me their hands if they've used it? Okay, two people, two kind of people. Well, it's a firewall with a natural language-like syntax. It's very simple to learn. I started with almost no experience in it, and within a month I was ramped up to what I would consider intermediate level. OpenBSD also can do a lot of routing things. Yeah, you can replace most Cisco functionality with it, even things like VRRP. You can do it with CARP on OpenBSD. Also, because it's Unix, there's a big win. You can use it with your configuration management system, in our case, Puppet. Now, you can do this. This is just a model I'm going to be showing you. So obviously, you can implement it using whatever you want. It just fits real well with PF. I know of a way to do it in Linux. It's not as elegant, but I can give you a high-level overview of that later on. Now, using this model, I'll start it for me in 2009. We had a project building a new data center. We needed redundant firewalls, this and that, failover automatic for VPN, for just the regular internet presence. It was going to have somewhere in the order of 20 network interfaces and at least 4 networks connected to it. Now, for this kind of thing, obviously, if you use Cisco or IP tables, you already have a headache right now. With OpenBSD, this was phenomenally easy, especially when using this model right here. I would come to appreciate this model more than anything. It was introduced to me, the idea of applying this from Multics to OpenBSD was introduced to me by Reich Floater. I'm not really saying Reich because I can't speak German, but he's a brilliant network engineer who is also an OpenBSD developer. Okay, so what are hierarchical protection domains? It's sort of an intimidating title. It's actually sorry, this thing with Linux is not the greatest. Okay, so hierarchical protection domains, intimidating title. It's not really an intimidating concept, however. You may remember this from college information security, rings of protection, they might have called it. And it dates back to Multics, which, if any of you remember, was the precursor to Unix. An interesting thing about Multics was it was the first time that engineers thought about security from the ground up. So one of the things that's crucial to this concept of rings is the reference monitor, which was a small piece of software inside Multics that would ensure that several rings could not access each other's data, basically. Now, this criteria is outlined in a very abstract paper that's available nearly everywhere on the internet. I can show you after if you're interested. But there's 3 requirements for it. It must be tamper-proof. This is basically, no one can get in and mess with it. Well, with OpenBSD, you satisfy this with traditional security methods, key cards, cameras, physical security guards, but fully tamper-proof. We all know security is impossible to be absolute, We'll get as close as we can with OpenBSD, in my opinion. Now, in operating system design, let me step back for a second. In operating system design, the ring model, at its very core, it's sort of like an onion. At its very core, you're going to have the kernel. Next might live device drivers that need to talk to the kernel, and next would live, user programs, userland, basically. So the idea is that people in userland can sometimes talk to device drivers through what's called a gate. the reference monitor implements the gates. Now, this goes side by side with OpenBSD's packet filter really nicely. We already talked about the tamper-proof part, but the monitor must be invoked for every reference to data anywhere in the system. This means this is obviously satisfied. If you have PF on, any network traffic is obviously going to go through it, so you satisfy that requirement. The last one is a little elusive. The monitor must be small enough to be proven correct. I don't think these days I could prove the simplest of mathematical equations, let alone a programming language. So there is some behavior-driven design software that can verify things are logically correct, but I haven't gotten around to yet implementing a way to test packet filter rule sets through that. I just want you to know that it's possible. Now, Unix...
So in your spare time, you know, crack around.
Unix does not do hierarchical protection domains. Unix is just basically user land and kernel land. Just thought I'd mention that there. So, now, this is a really simple visualization of what I've been talking about. Like I said in our example, our fake OS would be the kernel, drivers, and user land maybe. Now, our basic design for the firewall was 4 networks. At the center we have things like ILO, LOM, things that if they get compromised, you're basically up the creek. Someone can turn off all your servers and you're out of a job most likely. Ring 1, slightly stuff that can still do damage, but not so badly. And ring 2, you get to intranet, which you're almost near the end. And then ring 3, the internet. We call it ring X in our configuration, which I'll explain why in a second. One thing I do not like about Linux is it doesn't have PowerPoint. Okay, so this model fit well with what we were doing, but sometimes you have a common problem where your external IP range is obviously very finite. You might be given, you know, just a few addresses. So you have to load balance, right? You need to load balance your HTTP servers, your app servers, your SMTP servers. So what you can do is you can have a pool of servers in there, which you know, you can name ring 25. We double digit our rings, not to confuse the matter even more, but we double digit our rings for this case because later on we discovered, oh wow, we really forgot we need this in here. So luckily we double digited it, we added in at ring 25. And what you can do easily with packet filter is load balance in. Now, let me see here. Okay, now we get to really showing you why this is super easy. That's a packet filter rule. Pass in from 10.3.2.1 to 10.3.2.5 port SSH. Everybody in this room probably understands what that's doing without me even saying it. But just in case you don't, it's passing in from the first address to the next address on SSH. I don't think anyone is confused by that. Now, other things in packet filter that are really great are things like auto spoof, keywords that make it so if traffic is coming from an IP on an interface and basically saying on the local IP, I'm inside your network, but the interface is outside, packet filter, just by adding a line that says auto spoof on FXP0, is going to say no, you're not allowed in. There's no hackery involved, nothing like that. Everything in the whole language is very terse like this. I have more examples too for natting that are really nice. There's also scrubbing, automatically fixing malformed packets like IP fragment attacks, stuff like that.
Since I don't come from a security background, is there an advantage to fixing malformed packets rather than just denying them outright?
Sometimes badly written software sends you malformed packets not because it wants to be an ass to you, but because the programmer didn't design it right. I've seen in particular in high-level languages like Ruby, the lower-level libraries won't handle TCP right. So it looks like an attack, like fragmentation or something, when it's really just a problem in the code, not someone trying to DOS your router. So, route labels. Now we're going to tie it together into super easy. Okay, a route label is a 32-byte ID attached to a route in the kernel. It's not just a description though, it's usable. This means that in userland, the packet filter, as well as BGP among other things, can see the route label and make decisions based on it. So what we have here are two examples. Pass in from route ring 10 to route ring 20 and route ring 30. This is saying that if you're on the inside, you can hit outside resources going out the ring. Earlier in the rule set, you'd have a block in rule so that no one's going to come in. Now, that rule right there, if you've ever worked on a firewall or router with a lot of interfaces and networks, you're seeing the simplification here. At this job, when I last started, for every interface, there was two sets of rules, the pass in and the pass out. So you're talking hundreds of rules, the configuration over 1,000 lines for something that wasn't as complex as this. Now you've gone with this rule and introduced maybe at least 3 times less the amount of rules. And
it's human readable.
Yeah, that's the greatest part. I'm a big fan of Ruby and things like that that make programming and configuring things easy, human readable, leads to less errors. It's just great. Now, this next one, this is what I really love because nothing gives me a headache more than having to NAT when you've got 20 network interfaces. If you've got the route label set up and you say NAT from route ring 20 to route ring X, if you recall my example, the internet is always ring X because it's always at the end. So you're saying that if my internet servers need to access the internet, just NAT them out the external interface's IP address. The only part of that might be a bit peculiar to you guys is that last part, it's variable external interface :0. There's a macro early in the rule set, which is a variable that says this is my external interface, and :0 means the first IP address associated with that interface. Okay, now you're saying, well, that's just software, you know? How is this going to make my life easier in the physical realm? Because we don't just work in software unless we're really, really lucky sysadmins. So, I'm going to show you a couple things you can do if you're lucky enough to design your network from the ground up using this model, the security model, and you match things up like the subnetting and color coding and whatnot. It's made my life really nice. Now, network numbering. This is our fictional startup. What I did when we started was we were able to match up the subnets. So we took a class A and we said we're going to have this many racks, and we matched each rack number up to the second octet. Nothing fancy. It's just easy to follow, you know? Now, you do this also with the ring numbers in each rack, though. So what you end up with is each rack has its own ring network security set of rings, and the subnets match up, and then at your core router, upstream or whatever, you have them all converged into one larger ring. I can't tell you, the earlier part I was talking about configuration simplification, you know, which was great. You all saw it was human readable and everything. If you need to go in and do complex things, it's all grouped logically and you can get it done with one simple rule usually. This, though, is more of like a troubleshooting and maintenance fix, I guess you would say, because if if you're having a problem with some IP addresses in a certain range, because you've lined it up with racks and all this, you can make a fairly you know, educated guess as
It becomes
to,
intuitive to see what's
yeah,
in this
it's
packet.
very intuitive when it lines up like this. You can make a fairly educated guess as to where the problem might be. So next we'll talk color coding. This is not new to anybody.
You
I
didn't
know
invent it?
everybody
What?
has their own way of doing this. I've heard it done for, you know, voice, video, and data as different colors. But what I chose to do was to color code per ring. So what this lets me do is, if I see a plug going into any cable, I'm in behind the rack, I see a plug going to cable, I say, hey, that's on the wrong ring, that's why it's not working, it's not getting the right IP address. And stuff like that, it's so easy because of this. And because your subnets line up here, you're just basically an infrastructure nirvana. Any problems happen, you can track them down super fast. Someone calls you, said this computer is messing up, you go trace it out, you know what, a whole bank of ports failed on my switch. I have to order a new switch or a new module for my switch. This whole setup was made simple because of OpenBSD. Now, you can do it in other things, Cisco, Linux. It's just not as elegant. In Linux, you have marks and IP tables, so you'd go on your pre-routing chain, you'd mark traffic as belonging to whatever ring it is. PF also has tags, which are not quite as useful as route tables in my mind. But the mark, then you can later on say, if this mark is present, let it go to this other mark. Stuff like that. It's the one advantage this approach does have, the marking, is you can mark or tag traffic that isn't based on the IP layer. You can actually go a layer above and tag traffic based on ports. So you can do things like put a specific protocol, such as SSH, into an inner ring, thereby insulating the whole protocol. That kind of takes away from the elegance here. Hold on one second here. Okay, so I'm going to bring up a sample configuration of packet filter here, because the examples are supposed to have handouts here and so on and so forth. But let's see. Okay, maybe this will do. Okay. So you set a variable, if you remember from the NAT example, we had external interface. The block policy just says drop a packet instead of responding to it. Now we get down here to the meat here. We have one NAT rule that NATs the inner rings out to the internet through the external interface. You block in and you pass out. The way packet filter works may be surprising to the Linux admins in the room. It basically does last rule wins, whereas IP tables first rule wins. So you go down in ascending order here, do each of my rings, and the only thing in here is, if you recall, I talked about the reference monitor multics, and that was analogous to packet filter in this example. And the reference monitor had gates, so, like gatekeepers that allow certain things in. In the packet filter example, a gate is basically any rule. So here in the end we have pass in from route ring X, the internet, to what we can guess is an internal web server. So this is super readable. I've never encountered anything like this when I started with this project. So hopefully you guys see it too. Now the paper on the USB keys you guys have is a complimentary. This is where this is included. It's complimentary to the slides. The paper probably should have been a little more in depth, but time constraints and so on. So yeah, I got through that a little quick. Less errors. Everybody knows that if you have a really complex set of ACLs that you're just always adding, like I was told earlier by someone, you're going to eventually lead to letting network traffic in that you don't really realize you are. So more simplicity, better security. Ease of management is a great side effect of this security model when you're able to design a network from the ground up and align everything, the color codes, the subnets, so on and so forth. You could even do, instead of racks, data centers if you had you know, a bunch of data centers. So that's one thing I like about it a lot. Now, having this all together is a picture of a perfect infrastructure, so I realize some of you might be saying this can never happen, but it's possible, it's doable, it works, as long as you're designing from the ground up. I've never migrated to this. I tried once and it was very difficult because I was trying to go from an us versus them kind of firewall with a lot of, like I said, a pass in and a pass out rule for every interface, redundant links. It just wasn't really working too well. So I think the best way is if you design it from the ground up to move to this. So yeah, any questions? Finished super early.
How did you stumble across this?
Like I touched on earlier in 2008, I think it was, we had to build a new data center. People were crying because our web server was in a closet somewhere and always going down. They wanted something robust and all this. And so one of our developers from LA was an OpenBSD developer at one point and said, hey, I know a guy, he wrote all this stuff for OpenBSD, we have him come in. And we're like, dude, we cannot deal with this model we're using right now. We've got 2 rules for each thing. Like if you need SSH to go in, you need to pass it in. And because we're blocking a default deny on out at the time, you had to pass it out too to the box it's going to. This is for every interface. It's no joke how quick this rule set gets huge. So we explained it to him, and he said to me, well, do you remember Multics? And I was like, no, I do not remember anything from Multics. And so he was like, well, check out the rings of protection that they use for the security model. So I did, and I said, man, this sounds great. And everyone else is all, they're not even really with it, because they're not as Unixy as I am, I guess. But I was like, that's a great idea, man, so we should really do it. We did it, and that was it. I mean, a couple months later, I wrote a really short, this is why this presentation is so short, because it's almost brain dead simple. It's just not been done that much. I couldn't find that much information in Google, anyone I asked, who had really done this. Everybody's doing a DMZ, us, and them, which, you know, can lead to bloat and whatnot. It's really easy when you have groups. Group it in a hierarchy so people can't come in, but people on inside can get out. So simple idea. Any more questions? I hope.
Was it tough?
So how many interfaces do you have in each of these OpenBSD routers?
This one that this was done on was 20 interfaces. A variety of real interfaces, trunked interfaces, VLANs. That's another thing I should have mentioned with the subnetting. If you can match up your VLANs, you've got good segregation. Each bank of ports I showed you there, we set those to be an untagged VLAN. So it's another layer of security that anything coming in over those ports, we know is only going to be on a certain ring. We are guaranteed. So the OpenBSD ports then sit on trunked ports before they go to the internet.
Oh, okay, so you're using trunk ports.
Yeah, for the OpenBSD, then OpenBSD you can trust to do your VLAN tagging. Whereas, you know, if you make all your switch ports untagged, if someone were to own one of the boxes on a ring, they couldn't like just sniff traffic and fake a VLAN tag and get that traffic because the switch is blocking.
Okay, yeah, I'm just used to using layer 3 switches that, you know, do all the routing and ACLs and
Yeah, we leave the layer 3 to OpenBSD. I prefer it that way.
How do you, for this model, how would you compare it to something like Sidewinder security?
I'm not familiar with it.
Okay, it's similar to the BSD router reviews. It's something about like TAFE, but they have
I think we used to use this.
secure computing, G2.
I'm not sure exactly what the model entails. If you have a complete description, you want to chat with me about it, I can definitely do it over email. You know?
Yeah.
Anybody else?
Did you have a hard time selling BSD in that environment?
No, because as I said, Rapid7 is an information security company. One of our founders was actually Chad Lowry, who's an OpenBSD developer. So it was they actually had to sell it to me when I got there because it was badly configured and not maintained as well as Linux boxes because the expertise for Unix administrators is not what it once was now that Linux is so popular. So they sold me. I mean, I like it a lot. You guys should pick up some of the official sets. I encourage you to try it out, especially if you have any old Sparks. Old Sparks that are really slow. They work fast with OpenBSD.
Probably beyond the scope of this particular talk, but what kind of hardware did you use to get that many interfaces involved?
These we used some really beastly hardware for it, so we'll be able to scale for a while. HP DL365s.
I'm sorry, can you repeat that DL?
DL365s for routers. That's right. You did not mishear me.
Okay.
How many interfaces did you have then?
In each of those, there's 8 real ones, I want to say. And so as you start trunking and all this stuff, you end up with like 20-something. So we anticipate this setup will last for a while as far as hardware goes.
Can you talk about load?
Yeah, load is when we're getting a lot of web traffic and stuff like that. I've seen the load go up to like 20% in the system, so that's all packet filter. It's basically over-engineered. I'm not afraid to admit it, but I'd rather
it's a common practice.
I'd rather it be over-engineered and stay up, high availability and all this, than it goes down because it can't handle the load. That's more embarrassing as far as
it's the way to go if you can pull it off. It's the
Yeah.
easiest.
Yeah, they gave us the budget and everything because the old web server just wasn't hanging. So. Any other questions? I mean, I realized I talked quick and got through most of it pretty quick. General OpenBSD things I might be able to answer.
How long did it take you to adapt to BSD as a full-time environment? So actually talk about that whole experience. I mean, what was it like?
Yeah, it was like, I've used Unix various different types since I was like 12 years old. So, but I mostly used Solaris and various Linux distributions. So some Solaris things I recognized when I got to BSD, but I only toyed with it before. I never used it in a production environment. I actually had the misconception that it wasn't an OS4 production environment. Now, they have a very different philosophy from Linux people. A lot of people in the IT community find them abrasive and somewhat hard to deal with. But I think they're awesome because they stick to their code. You know, a man's got to have his code and they stick to it. So the code quality is great. For me, it was just picking up some new commands and stuff, getting used to certain ones not being there that are in Linux. Like, instead of strace and ltrace, you have ktrace. Just stuff like that. I mean, it's not a huge paradigm shift, but it's enough you'll have to work at it, you know? Now I'm pretty comfortable with it. I was running it on my laptop right here, but since I'm going to have to migrate to Ubuntu 10.04, my servers, I figured I'd throw it on my laptop and start using it. And I was having a software key dropping problem that I couldn't find.
Have you thought about virtualizing other services when you go drivers?
I mean, I think the biggest challenge is, you know,
modules instead of ideas on there?
Well, I actually, because like I said, it's so over-engineered, if we end up putting an IDS in front like that, I wouldn't even virtualize it. I just run it right there. Because I mean, like I said, even during traffic spikes, the most we'll see is 20% on either router. So.
Because with the Sidewinder model I was talking about, they actually run like an internal and external. There's like 3 rows, 3 separate areas, so they actually have the DMZ on the box.
Mm-hmm.
And part of that DMZ are like they have like a DNS server on the external, or DNS server on the external, middle, and internal, and they all pass back to each other. And we have the same thing for SMTP. They have the same thing for.
You know, this is a model of a router of one of the routers I had to deal with when I started.
They pass to each other, right? It's like having a whole network like on one box.
Yeah, that's basically what it was. Now this does have a bunch of networks that go through it, but that Sidewinder model, which I used on one of the routers, was very difficult to maintain, to say the least.
It is very
It
difficult.
makes your brain turn to mush. Quickly. That was one of the ones where you got to pass in and pass out for
Yeah.
a million different things.
Yeah.
Eventually,
Everything has a user count.
you're TCP dumping everything. You're like, why isn't this traffic going? I just need to get it to Nagios so I can monitor the blocks. It's just a total pain. And you don't get security by that. It's such a misconception that you need to deny everything to have security. You can be secure and simple in this model, and you don't really lose much there. If someone's going to get out, they're going to get out. If someone does a reverse shell, they'll go out through HTTP, because you need to leave that open anyways for people to use anything.
You know about how to second route between the two blocks?
I don't know that, but I know it's probably more than our site will ever need. It's a lot, I can guarantee that. I can try to systat. I can systat it for you and send it via email, because
You compared to like
I know Cisco would go faster because Cisco's got this design hardware for routing. The reason we didn't use Cisco is because we don't have the in-house expertise. OpenBSD was entrenched for our network devices, and we can't tie Cisco in with our configuration management. So we can run anything on these, you know what I mean? Like, we need to run syslog, our syslog SAR, collect all kinds of stuff, and with Cisco you're pretty limited, even though you will get better speeds. They're very limited in scope. This is Unix, do anything you want. What? Oh yeah. What's up, Kyle?
Well, so could you talk a little bit more about how you're using Puppet to manage this setup?
Yeah, sure, definitely. So my Puppet modules, basically, when you include a module in my Puppet setup, the initialization of it has a case statement that says if you're this OS, get this class. If you're this OS, get another class. So what I do is I set up an infrastructure group that's going to have all the admins and get all the admins. I install packages that I expect to be on every system, such as the new screen. What else? rsync doesn't come in base. There's a lot of things that aren't in base in OpenBSD that you're so used to in Linux, you can't get much done, So I install all those packages. I have PF served out by domain. So like if the domain is whatever.rapid7.com, there's a file sitting on the file server in Puppet, pf.conf.whatever.rapid7.com, and it gets served out. I recently moved that. I used to do OpenBSD configuration deploys through Subversion and Capistrano, because syntax checking is built into anything OpenBSD writes, the HTTP, PF, the IPsec control. They've all got verification functions to make sure you have no syntax errors in your configs. So when I write a pre-commit for Subversion, number one thing I do is syntax checking. Well, you can't do syntax checking for OpenBSD configurations on Linux. So I had to work a little magic into the manifest in Puppet to not apply bad rules, to email us if we've done something wrong in the rule set. But the Capistrano deploy was fragile. You would deploy something and say the permissions got screwed. You have to use mtree. I don't know if you're familiar with it. It's an old BSD utility. that based on permissions in a text file, it applies those permissions to a directory structure. So you have to run mtree off the root, and God forbid in the middle of this you destroy sudo permissions and lose your ability to become root, and you have to ILO in, so on and so forth. So yeah, that's about it with Puppet. It's so easy that because they're conditionals. I mean, you can really get anything done.
Do you use it to stand up entire machines or just for configuration at this point?
Well, standing up machines with OpenBSD, I have a Puppet class that actually builds a PICC server, and we just reboot it with ILO and choose OpenBSD to upgrade, and the installer from 4.6 and the new 4.7 will probably be nicer. You just hit enter like twice and it upgrades. You should read the release notes before you do this, because sometimes there are PF syntax changes, and you need to make sure you're not booting up with no rules, etc. So
I'd like to assume that I test.
well, the idea is for when I build any system is to build the smallest amount possible and then let Puppet do the rest. It's kind of becoming a practice, I'd say, in the industry.
Well, it makes sense if you can pull it off.
Yeah, exactly. Because if you don't do that, you're gonna end up with like image sprawl and stuff like that. Not nice. Geez, this is so simple that I finished at least 15 minutes before. I doubt anyone else has any questions.
Actually,
Okay.
there is only 5 minutes until the keynote. So
Oh, really?
you're not.
Okay,
good.
cool, awesome,
Thank you
awesome.
very much.
No problem.